Let's see another problem based on queue data structure. So it's a binary tree side view, and for this we want to get this right view of this binary tree. So if you see this example, we can see in the output 1 3 4. And how will you do that? We'll traverse each row and we store this data in a queue, and also we remove the item from the queue and we check that's a last item in a queue and we add in a result. In a similar way, we add this in a queue 2 3, and we also remove the item from the queue and we check the last item in a queue, and if we find this, add in a result. We'll do for the last row also. So this is the row level traversal, and from the queue we'll add this item in a result and we can return that. So how will you do this? Check the logic here. So it's if you see the root nil, return nil, and we can create a queue and we can add the first item 1 in a queue. So that's good. And we can check, okay, queue length not equal to 0. We know there is a 1 in a queue. Okay, so it's not 0, it will come inside. We'll find the row length. So this is one row, so the row length is 1. So we store this in a row length, and an inner loop, that's a checking if the row length greater than 0. We know that row length is greater than 0, that's a 1. We'll remove one item from the queue, and then as soon as we remove the item, we'll decrement row length. So row length is 0 now. So then we'll check this condition. If row length equal to 0, add that item in a result. So we added 1 in a result, and we also check if there is a left node or not. So if left is not nil, then we can add 2 in a queue. And we also check if there is a right node is not nil, we can add this 3 in a queue. So we'll come out of this row length because row length is already 0, but it will get stuck in an outer loop. And here it will check queue length. So we know that we have already added 2 3, so queue length will be 2. So that's why it is in outer loop. We'll calculate row length again, and this time row length is 2. Again we remove the item, so we'll remove 2, and we'll check row length equal to 0. No, it will not go here. For 2 it will check left and right. We'll find 5. We add the 5 in a queue, but row length is decremented, so that's a 1. And then it will come again. It will be inside this inner loop, and this time we'll remove 3. So we'll remove 3 from the queue. Row length is equal to 0 now, and this time if the row length is 0, then we can add result. So now this time we can add 3 in a result, and for 3 again we'll check left and right. If you find, we can add that in a queue. So we can add 4 in a queue. So in a queue there is a 5 and 4. For inner loop is done because row length is 0, but it will get stuck in outer loop. We again calculate the length of row. So we know there are 5 and 4 in a queue, so row length will be 2, and again this will run for these 2 items 5 and 4. We'll remove one item, we'll remove 4, and when this is last item, we'll checking row length equal to 0. If it's the last item, you can add that in a result. So that's a result here, and we can return that data. We can see the Java solution. So same logic for the Java solution. The root null, return empty. We have result, that's we are going to return, and there's a queue. We can add the first item, and we can check, that's outer loop. We can check queue size is greater than 0. We calculate the row length. First time is a 0, and then we'll run the inner loop. If the row length is greater than 0, we'll remove the item. We'll decrement the row length, and we'll check if row length equal to 0, add that item. So in the similar way, we can go for second row and third row. So that's all for today. Thank you.